The Tibetan Plateau is also known as the Roof of the World. The name, the Roof of the World, is not given lightly. The formation of the Tibetan Plateau started around 55 million years ago due to a collision of continents. The region of present-day India collided with Tibet, forming the most extensive mountain region in the world. The Tibetan Plateau has vast peaks that are the highest in the world. Its immense length spans over 2.2 million square kilometers, which is around 5 times the size of California, and an average elevation of 4,500 meters. Its enormous length and size can be seen from outer space. This has not gone unnoticed by the world. Its grand nature led the UCLA Geography Department and lead scientists to explore various questions. How can we examine the change of the physical features, biological features, and cultural landscape of Tibet? What technology and methods are out there so we can monitor the change that surrounds this phenomena? As temperatures begin to increase, scientists and geographers around the world study how this will impact Tibet's environment. Tibet is a unique landscape because it is mostly uninhabited by humans. This allows for a unique opportunity for geographers to see how climate change is affecting a region largely undisturbed. An NSF grant allowed UCLA's Geography Department to combine previous research focusing on individual areas of expertise into one collaborative project in order to predict the future climate of Tibet. Professor YongKang Xu of the UCLA Geography Department leads the effort in researching climate change.
In this NSF project, we will put this thing all together. We will study those together, include global warming, how those processes, those things affect the East Asia climate. And also we try to do for the future, how the future will be, give a more reliable answer. In the process, we particularly want to develop a more realistic climate model can address the issue today the society want to know.
A plateau is a flat, elevated landform that rises above its surrounding area. The Tibetan Plateau surrounds all of the Tibet Autonomous Region and most of the Qinghai Province and extends into western Sichuan Province and the southern Uyghur Autonomous Region of Xinjiang. Around the southern edge of the plateau lies the Himalayas, which is the greatest mountain range on Earth. It is 6,000 to 7,000 meters above sea level. At the center of this range are 11 of the world's highest peaks. Chomolungma, also known as Mount Everest, is 8,848.13 meters, making it the world's highest point, truly making it the roof of the world. Due to its immense length and height, the Tibetan Plateau has a varied climate. The region's climate is shaped largely by the winds, which interact and affect the landscape of Tibet. The westerlies winds make their way across the northwest to the southeastern region of the Tibetan Plateau. The South Asian monsoon arrives from the southwest, moving its way to the northeast, while the monsoon also flows from the South China Sea, reaching the eastern Tibetan Plateau. As these modern westerlies and monsoon interact, their chain affects land surface over the Tibetan Plateau. As temperatures around the world continue to increase, there is evidence of it affecting the Tibetan Plateau. The region is heating up twice as fast as the global average, and the temperature has increased around 0.54 degrees Fahrenheit per decade. Temperatures can drop below -30 degrees Fahrenheit and can even go as cold as the poles in the winter. In the summer, temperatures can skyrocket to over 100 degrees Fahrenheit. The change in climate surrounding the plateau affects the natural glaciers in the region. The Tibetan Plateau contains some of the largest volume of ice that is outside of the polar regions. This has led some to refer to the Himalayas and the Tibetan Plateau as the third pole. Recent advances in satellite and ground station data have led to a new frontier in climate modeling. Using new and sophisticated computer systems, scientists can create the most comprehensive climate models to date in this region, potentially showing what the Tibet climate will look like in the next 50 years. Climate modeling is an attempt to recreate the Earth in a computer program based on the physical and mathematical principles found on Earth. Historically, climate models have been an oversimplification of various physical and dynamic processes that occur. Today, climate models include various factors such as ocean flow and chemical processes, atmosphere and land interaction, and greenhouse gases that contribute to a more accurate depiction of the Earth. In order to calculate the complex processes around the globe, the Earth's surface is divided into many small grid boxes. Each grid box is designated a different category such as farmland, urban, desert, and more. Once this is established, scientists must consider vertical as well as horizontal interaction between the atmosphere, land, and the ocean. The Earth's systems are all described by mathematical equations. Once the real-world climate is replicated, the same process can be used to predict the future climate with different values. To try and develop such a comprehensive Earth system model to represent the real world, an interdisciplinary collaboration has brought together scientists and geographers to engineer the most realistic climate models, which take into consideration these multiple real-world factors such as water, carbon, nitrogen cycles, ecosystem, aerosol, land use change, and many more. One of the most challenging aspects in recreating the Tibetan Plateau is trying to develop a realistic approach to snow and permafrost land in the region. Traditionally, the water cycle functions with ocean and land evaporation, followed by precipitation, which contributes to surface flow, and groundwater flow, which makes its way back to the ocean. This is a challenge because in the plateau, closed lakes do not flow back to the ocean and instead evaporate and create salty lakes. Climate modeling is used to find specific patterns in the environment to define processes such as this. To find these specific patterns, researchers must reconstruct the past climate, monitor the current climate, and then compare the past and current climate to find specific patterns and changes occurring on the Tibetan Plateau.
When we say data analysis in my group, we mean that we look at the observational data and the model data, and we use advanced mathematics and statistics and computing tools to make analysis. We make also fancy matrix operations, statistics inference, and then try to find out the characteristics of the Tibetan Plateau's climate. For instance, so can we find the pattern of Indian monsoon? Can we find the pattern of westerlies? Can we find the pattern of Eastern Asian monsoon that goes from Shanghai, from East China Sea back into China? And so this numerical analysis, they come out with numerical results of those patterns and those characteristics.
The Nyankantangala Range, to the north of the middle section of the Yarlu-Zanbu Valley, has more than 5,000 square kilometers of glaciers alone, which is by far more than the glacial area of the European Alps. Glaciers are a body of moving ice, and along the northwestern region of the Tibetan Plateau, they are increasing. In the southern side of the Tibetan Plateau, along the Himalayan mountains, the glaciers have been shrinking. The glaciers of the Tibetan Plateau act as reservoirs of fresh water. When summer arrives, the glaciers release a massive amount of water that fill up rivers and streams. The plateau's glaciers are a vital sustenance to the world. The ice creates some of Asia's largest rivers. 10 rivers originate from the Tibetan Plateau and stretch all across Asia. The Yangtze, the Yellow, the Mekong, and the Ganges rivers have historically nourished civilization. They provide nourishment presently to the drylands of Pakistan all the way to northern China, which is 3,000 miles away. Around 2 billion people and a third of the world's population depend on the snow and ice of the plateau region. Professor Yongwei Sheng studies the impact that the surrounding lakes and rivers have on the Tibetan environment.
Over the past several decades, both the glaciers and lakes on the plateau changes dramatically, especially for the lakes. The lake changes over the plateau is considered to be the most dynamic area on the Earth. And because the most of the lakes on the plateau located in dark basins. That means there is no water flow out of those lakes, and making those lakes really sensitive to the climate change. The increased temperature would increase the evaporation, but in the meantime, over the past 20 years, over the Tibetan Plateau, the temperature, the precipitation also increased largely. So as a result, the net balance between the precipitation and evaporation, and also glacier melting, that making the Tibetan lakes increase.
Climate modeling allows researchers to see how the melting of glaciers causes an increase in precipitation, evaporation, and lake expansion in the Tibetan region. As temperatures increase, the glaciers begin to shrink and release their water. Glaciers surrounding Tibet have shrunk 15% over the course of 30 years. The result is a rapid increase in the amount and size of lakes in the region. The lakes are the fastest growing in the world. The ensuing result is visible clearly from space. An example of this rapid lake expansion is the case of Xiling Lake and Namu Lake. In 1976, Xiling Lake, located on the Nian Kantangala Mountain, was the size of 1,800 square kilometers, and Namu Lake, located to the north, was 1,900 square kilometers. Over the subsequent years, the lakes expanded over 30%. Xiling Lake expanded at a much higher rate than Namu Lake, and by the year 2005 surpassed it. Even though the lakes are the fastest growing on Earth, there are some lakes that have shrunk in the Yarlu Zanbu River Basin, located on the southern region of the Tibetan Plateau. Although these lakes are shrinking, in the Chantan Plateau, the northern region, the rivers are significantly increasing. Along with the expanding lakes, there has been some change to the precipitation patterns of the region. Most of the precipitation surrounding the Tibetan Plateau has either increased or stayed the same. However, there has been a decrease in precipitation along the Himalayas, the southern region of Tibet.
For the precipitation in Tibetan Plateau, it's basically, in most part, it's increase. But in Himalaya mountain area, so that part precipitation will decrease. But overall, the precipitation will increase by about 10%. And meantime, because the temperature warming, precipitation change, so in most part of Tibetan Plateau, the glaciers will retreat because it's melt. And also, in particularly in the southeast Tibetan Plateau, when the precipitation actually was reduced, so that part so the glaciers were retreating. But for the western part of the Tibetan Plateau, because the precipitation increase and the temperature warming is not as strong as other parts, so actually the glaciers will increase slightly. But overall, it will reduce. And so there are many photos that people took in past 50 years shows how fast the glaciers was retreating. And in terms of runoff, because we have more glacier melting, snow melting, we have a little bit more precipitation overall. So the runoff in general in Tibetan Plateau is increased.
Precipitation as well as temperature have a strong impact on the vegetation in the region. Some of the main vegetation zones include alpine, grassland, meadow, desert, and forest. Professor Thomas Gillespie and his team worked together and used the latest satellite data to recreate the vegetation around this region.
What we do in geography is we use satellite imagery from spaceborne sensors. In particular, at 1 kilometer resolution, you can look at change on the Tibetan Plateau over the last 30 years. And at 250 meter resolution, you can look at changes in vegetation across the Tibetan Plateau at about 250 meter resolution. What we do is we have this greenness index called NDVI, and it just uses the visible and infrared bands. And what it does is it tells you the greenness, or the amount of photosynthetic activity and plant productivity. Looking at how the greenness has changed across the plateau and within these parks, we can see, for instance, patterns that occur. And most of these patterns do look like they're related to population. So we have maps of population of Tibet that go back to about 25 years. And examining how people are moving throughout the Tibetan Plateau lets us understand how the vegetation is changing.
The Tibetan Plateau contains some of the highest vegetation zones in the world. The plants in the Tibetan Plateau experience different blooms and greenery based on their location. The northeastern part of the Tibetan Plateau experiences an earlier bloom, whereas the southwestern region experiences a later one in the last decade. One of these vegetation zones located on the Tibetan Plateau is called the alpine. An alpine plant is vegetation that grows above the timberline. At 4,500 meters above sea level, this altitude gives way to a variety of species of shrubs and herbaceous plants. Alpine plants often face harsh conditions of the alpine environment, such as low temperatures and dry weather. The alpine vegetation is unique because of its adaptive nature, but the grasslands are what make up most of the Tibetan vegetation. 70% of the total land area is made up of grasslands. The grasslands on the Tibetan Plateau are diverse due to the immense size of this region. They are unique because they can withstand harsh winds and varying climate. These grasslands are a vital sustenance to inhabitants in this region. The marshy meadows are scattered all around the large grasslands where there are small pools and low-lying ground. The grass that sprouts in these areas sprout earlier than everywhere else. In addition to vegetation, a new factor contributes greatly to the environment of the Tibetan Plateau region: humans. Where humans decide to live plays a critical role in the environment. Humans affect the climate in a multitude of ways. Recently, land use change plays an increasingly important role on the future environment. China has designated 4 of the world's largest nature reserves in the Tibetan Plateau. Inhabitants and nomads were removed from the designated areas, resulting in a dramatic land use change in an area larger than Japan.
So when we study nature reserves on the Tibetan Plateau, what we do is use satellites to see what the vegetation was like before the nature reserves were created, and then what happened after these nature reserves are created. What's kind of interesting about China and Tibet in general is that there's an international accord where every country has to have 18% protected areas. China being a huge densely populated country, the best place to do this is in high elevation areas where there's very few people. So about 15% of the protected areas in China occur on the Tibetan Plateau. And this is where they created the world's largest nature reserve. Since 2000, China has created 4 massive nature reserves that cover an area larger than Japan. When they created these reserves, they went in and removed some of the native people that lived in these areas, and this was to ensure you wouldn't have hunting and grazing competing with native species. What this has resulted in has been a slight increase in greenness in some of these areas where they've removed the people.
The species that inhabit the Tibetan Plateau are diverse. This land holds over 798 species of vertebrates and 2,305 species of insects. 125 of these species are under government protection, including 2 animals distinct to the plateau, the wild yak and the snow leopard. The yak in the Tibetan region is both domesticated and wild. Wild yaks are found mostly in the Qinghai province. These furry animals live 3,000 to 5,500 meters in different vegetations of the Tibetan Plateau. Just like the wild yak, the snow leopard adapted to the harsh environment of the Tibetan Plateau. The elusive snow leopard has a beautiful white coat with soft brown spots, which allows them to blend into the snowy environment of the Tibetan winter. Snow leopards have thick fur and small rounded ears that are perfect for living in a harsh, cool environment. These animals are found at very high altitudes, between 3,000 and 5,000 meters high. The snow leopards live on the northern side of Tibet and unfortunately are listed as endangered. There are fewer than 7,500 snow leopards globally. Like the animals inhabiting this land, the people of Tibet have adapted to this harsh climate. People have been inhabiting the lands of Tibet for over 8,000 years. The earliest inhabitants of these lands were pastoral people. They herded goats, cattle, and sheep. They soon learned how to irrigate their lands and raise herds. Now, today's inhabitants come from a variety of backgrounds, which include Tibetans, Menpa, Lopa, Han Chinese, Hui, Sherpa, and a few Deng people. The native Tibetans are still the majority of inhabitants. Climate modeling is used internationally to understand our surrounding environment. Many climate models from different countries have been inconsistent in accurately projecting the future climate of Tibet. The one consistency among all these models has been an increase in warming throughout the region if conservation measures are not taken. The only way to reduce or decrease the warming is to limit greenhouse gases in the environment. The model from UCLA shows that without conservation efforts, the warming may increase by 1 or 2 degrees in the next decade. Even though this does not sound like much, this small increase can throw off entire ecosystems. Precipitation will also change based on this model, with an increase in overall precipitation throughout the plateau, but this is not the entire story. Certain areas will experience drastic changes in precipitation, resulting in drought, whereas other regions will have an increase of precipitation. As models continue to improve and become more advanced, climate researchers will be able to make more localized and accurate predictions.
Overall, as a whole, the model indicated in the future, if we have a more conservation measures, temperature, for instance, in the Tibetan Plateau maybe only increase one degree or 2, But if you don't control the greenhouse gas, it could be increased much more. And for precipitation, it's in general speaking, it will show a little bit increase overall, but that was in the larger, in the over Tibetan Plateau. As I mentioned, In the past, overall Tibetan Plateau has precipitation increased, but for some areas, some parts, precipitation was decreased very dramatically.
For a period of time, the harsh environment and lack of continuous observations in the third pole region kept researchers from understanding the different processes in the Tibetan Plateau. In the past decades, scientists and funding agencies from all over the world have made great efforts to establish projects and networks to carry out joint interdisciplinary research in the third pole region. These efforts will help society better prepare for understanding changes in the environment.